in the prolonged fast state, we have a very, very long fast that the glucose itself is not sufficient to meet the energy needs of the body. And then we would have a very increased lipolysis. So breaking down the fat tissue in order to use the fatty acids and triglycerides in order to maintain more energy. Now, this action would be done all over the body, so the fatty acids and the triglycerides from the muscles and the adipose tissue would be broken down. That's one thing. And we have something else which are called ketone bodies. And the ketone bodies, they are, let's say, another form of acetyl-CoA. So we have acetyl-CoA. Acetyl-CoA changes into ketone bodies, and then the ketone bodies would go into the liver and change once more to acetyl-CoA in order to produce energy or be used in the process of protein synthesis, fatty acids, and all of that. So the ketone bodies, we can call them like a transitional state in this cycle. The ketone bodies would be also used through this process, and this would break the cycle. Now, the ketone bodies, for example, they could be used by the brain, and this is what we mentioned in the beginning of the video, that the brain in the prolonged fast state will change its mechanism of obtaining its energy needs. So normally we mentioned that the brain directly uses glucose. Now the brain could use ketone bodies, and in very, very prolonged fast states, like let's say after 2 weeks of continuous fasting, the brain would be using ketone bodies in order to obtain 2/3 of its energy and glucose for 1/3. And this would affect the proteins, because this would spare proteins. Now you're breaking down proteins too in order to obtain the ketone bodies, and of course this would have a lot of side effects because this step is broken. So this is how the brain would change its ability to obtain its energy. It uses ketone bodies in addition to glucose. On the other hand, the red blood cells, whatever happens, would still use their own mitochondria if they have mitochondria at that point of time after this prolonged fasting. So the red blood cells which have mitochondria are gonna use glucose in order to maintain their energy. Otherwise, if they don't have the mitochondria, they will die and they will not obtain their own energy. So red blood cells, they do not use ketone bodies in order to obtain their energy, on the contrary to the brain and the nervous tissue, of course. So these were the three states of energy metabolism in the human body. Now I'd like to sum up what we mentioned in this video and mention a couple of notes. So the organs that we talked about, or the structures that we talked about, are, we have the liver, we have the resting skeletal muscles, we have the cardiac muscles, adipose tissue, and the brain, and the nervous system, of course, and the red blood cells. And why I mentioned skeletal muscles and cardiac muscles, due to the difference of their preference in energy metabolism. So here we have two states, the well-fed state and, let's just say, generally fasting. So what does each of these structures prefer for an energy source? So the liver would like glucose and amino acids. So amino acids are used for oxidation processes in the liver, and of course glucose, as we mentioned. And in case of fasting, we use fatty acids. Fatty acids. How about resting skeletal muscles? Resting skeletal muscles would prefer glucose, while the cardiac muscles, they would prefer fatty acids. And there's a difference between the cardiac muscles and the skeletal muscles, because the skeletal muscles are voluntary muscles, while the cardiac muscles are involuntary. So actually, matter of fact, in the second state that we mentioned, which is the post-absorptive state, the action of glycogen or the decrease of insulin and the rise in epinephrine that leads to the discharge of fatty acids and triglycerides from the muscles and the adipose tissue. What we meant is just the skeletal muscles, not the cardiac ones. So this is a very important thing to note. Now, this is for the well-fed state. For the fasting state, the resting skeletal muscles would prefer fatty acids and ketone bodies. The cardiac muscles would also prefer fatty acids and ketone bodies. And then we have the adipose tissue, glucose in the well-fed state, the brain and the red blood cells, the nervous system, all of them would prefer glucose in the well-fed state. In the fasting state, the red blood cells would still stick with glucose. The brain and the nervous tissue would also stick with glucose, but in the prolonged fast, as we mentioned, they would change their mind and go with ketone buddies. So ketone buddies in the prolonged fast. And for the adipose tissue, we would have fatty acids. Fatty acids. So that was a summary of what we mentioned in the video. I hope it was easy and clear. It's very, very important to understand this concept in order to know in the following steps of energy metabolism how everything works, what goes where and why and when. So I hope this video was easy and clear, and until the next time, I thank you for watching and see you.